All right. So this is 12 and 13. It is probably going to take 2 videos just because there is a lot of notes. So a lot of me trying to explain some things to you. It's all about sound waves and hearing. How do we hear different things? Okay. So remember, sound is a form of energy that results when vibrating materials produce longitudinal waves that travel through a medium. Gas is a medium. Okay. Oxygen is different than argon, is different than nitrogen, is different than carbon dioxide. And when your sound, your voice is traveling through the different gases, it can travel faster or slower. Vibration, told you before, if you put your hand on your throat and you say, you can feel the vibrations coming from your throat. They're creating a longitudinal wave, which is the ones that goes like this all the way to your ear. Speed. So sound travels through air at a speed of 342 meters per second. Okay. Meters are 39 inches. 1 meter is 39 inches. So take 3 rulers back to back and add 3 inches. You're getting 1 meter stick. Meter sticks, I have them in the closet. Big. Okay. 342 in 1 second. Like 3 football fields, y'all. Okay. Because particles in solids are closer together, sound travels fastest through a solid, slowest through the gas. Okay. Solid molecules are tightly packed, so you say something and it just moves right along. Gases, it's, hitting the different particles in the air to move. And I showed you the picture in class. And the other way to think it is 342 meters in a second. Y'all aren't that far away from me. That's why you hear what I'm saying as soon as I'm saying it. The speed of sound increases as the temperature increases. Why do you think that is? Okay. Temperature makes the molecules move faster. Like when you add heat to water and it starts to boil and changes into the gas. Okay. If you have heat in the gas, it's making the molecules move faster. So they're hitting, bouncing off, going crazy. And they're moving faster than when it's just colder. That's why sometimes people say it's harder to hear when it's cold outside because the sound, especially if I'm yelling from my room all the way down to Coach Tate's room, it's going to take a little bit of time to get there. If it's colder, there's when it was warmer outside and your voice can travel quickly. Because sound travels from particle to particle, it cannot travel through empty space. The moon has no atmosphere, no sound. That's why they have to bring their own oxygen, okay, so they can talk to each other. That's why if you're in empty space, you can sit there and go, as long as you want, and nobody's going to hear you because there's no sound. There's nothing for the particles to move the sound through. Yeah, sorry, y'all. Sound is much slower than light. So, which is why you see lightning before you hear thunder. You see lightning because it's faster, then you hear the thunder. That's why you say, okay, lightning, and you count 1 Mississippi, 2 Mississippi, 3 Mississippi, and then you hear the thunder. Well, then people say, okay, that's 3 miles away because light gets to your eyes before the sound does, even though they both occur same time. Okay. Dry air. So this is speed of sound in different mediums. So if it's just going through the air at 20 degrees Celsius, it's 342 degrees. Water is 1,498 meters per second. And in cast iron, like the skillets, maybe your grandparents or your parents have, and they're iron, they cook really fast usually, 4,480 meters in 1 second. If we're trying to send a sound through iron. So intensity and loudness. Intensity of sound is the amount of energy it carries. Intensity is measured in the unit called decibels. Intensity ranges from 0 decibels to 120, and that's the threshold of human hearing. That's when it's painful. We'll talk about different things like going to a rock concert or, the screeching, different sounds, loudness. And so intensity, oh, hey, it's loud. Well, that's how much energy it's carrying. Same thing with people with me. Oh, you're yelling. And I was like, no, I'm loud. I have a lot of energy when I speak compared to some other people that you may know. So loudness